So I want to tell you a story that starts a long time ago in a galaxy far, far away. Yes, I'm a Star Wars nerd, but this story doesn't involve Jedi, and for you Trekkies, it doesn't involve Captain Kirk or Spock. This story comes from the science of Albert Einstein, and our two characters are a pair of black holes. And I have a picture of them up here. So I'd like to kind of help you get a visual of what these two objects look like. So if you took the distance between here in Yakima to Mount St. Helens, that's about how big one of those black holes would look like. And we have two of them. And so they're about the same, except for their masses are slightly different. So one of them, that big object, has the mass of 36 suns thrown into it, and then the other one has the mass of 29 suns thrown into it. So these are strong gravity objects. And what does that mean? So strong gravity means that for these guys, their gravity is so strong that they actually bend and distort the space around them. And so that's a kind of a mind-boggling thing to think about. But the other thing is that if you take those objects and if you move them in space, so if I'm limited to the circle, so I'm going to just walk in a circle. I have one of the black holes, and if I was to walk around in this circle as holding this black hole, as it's moving, it's going to be causing a wake, like a boat on a lake, and making waves in that water. And so those waves, or vibrations in the space around it, are called gravitational waves. And because they're waves, they carry information about where they came from. So our story involves these two black holes, which were captive in a dance together. So they were both falling into each other. They were in this dance, and it was probably for millions of years. And one thing about this dance is that every time they orbit each other, they go faster, and they also get closer to each other. And for most of that million years, the dance was pretty boring. So what we're going to focus on is the very last moment of the dance. So at the very end of those million years, each of those black holes are reaching speeds of over half the speed of light. So it's hard to visualize that, but they're going very fast, and they're actually bending the space and warping it just violently. And so they're very close as well. So they're started out here, they get closer and closer, faster and faster, and then they crash into each other. There's an explosion of gravitational waves, and then a single black hole is formed, and then everything goes quiet. That single resultant black hole is about the size of Iceland. And one way to also think about this is to think of a lake. And what if you had a rock and you drop that rock into the lake? When the rock makes the splash, it makes a big wave, and then you see a ring of waves that come from it. And the rings get bigger, and the waves get smaller as they move away. So it's similar for our signal that we have. When the two black holes crash into each other, they make an explosion, but instead of a flat wave like on a lake, they have a spherical event that moves in all directions. And that event, or that signal, moves at the speed of light. So now, at that same moment, on our young planet, there was very simple life in the blue waters of our Earth. The life forms that were in the water had no idea of these two black holes crashing into each other. But they would evolve, and they would eventually evolve into an audience. So what I want to do now is just take these two seemingly different stories and follow them in history. And eventually they do have a cosmic connection later on. So 1.3 billion years ago, that's when the two black holes crashed into each other. And that's when the signal from that event happened or started. 1.3 billion years ago here, we just had single-cell life here. And nothing really happened for the next 100 million years. And so not much happened except for the signal traveling through the universe. And all the while, the gravitational wave signal keeps rolling on. And now I'm going to go a billion years after that collision of the black holes. And that's roughly 300 million years ago. Dinosaurs are roaming the Earth, ruling the Earth, and then they become extinct. And all the while, that gravitational wave signal keeps rolling on. Now I'm going to take another big step to 200,000 years ago. This is when the first human makes a footprint on our planet. civilizations rise and fall, wars are fought, poetry is written, people fall in love. Astronomers start to look at the sky, and history plods on. And all the while, that gravitational wave signal keeps rolling on. Now we're going to go back to the signal. So now we're going to go back to 50,000 years ago. And at this point, that signal is just beginning to enter our galaxy, the Milky Way. And it continues its trip through our galaxy. So now I'm going to focus on the very last moment of our history, so just a blink in time, and I'll focus on specific dates. So the date of March 14th, 1879, in Ulm, Germany, a young baby by the name of Albert Einstein is born. And all the while, the gravitational wave signal from our black holes keeps rolling on. And then I'll move another 35 years to the fall of 1915. Remember that year, 1915? That's when Albert Einstein finishes his lectures on general relativity, and he basically puts the scientific world on its head with his new way of looking at the universe. He explains gravity in a completely different way. Jana Livin kind of explained it in her talk. But basically, in effect, instead of objects being attracted by a force, Einstein came up with it in his head that all objects, all matter, bend the space around them. And it's this bending which is what gravity really is. And all the while, that gravitational wave signal keeps rolling on. Now I'm going to fast forward to 1972. This is near Boston, Massachusetts at MIT. There's a professor by the name of Ray Weiss, and he detailed in a paper how to make a gravitational wave antenna. And so essentially, this is when LIGO was born. And LIGO stands for Laser Interferometer Gravitational Wave Observatory. That's 1972. And all the while, the gravitational wave signal keeps rolling on. Now we're going to move 25 years later to 1997. This is when both LIGO detectors their construction was completed. One was in Louisiana, and then this one is a short drive down the Yakima River Valley to the Hanford site here in Washington State. Essentially what these detectors are rulers, because what they measure are distances. And the distances that we need to resolve to be able to detect these tiny signals, the distance we have to measure is 1,000 times smaller than a proton. And this is the sensitivity that we need for this machine, because the signals that we're looking for are far away, and they're very small by the time they get to the Earth. And all the while, the gravitational wave signal keeps rolling on. I'm going to just take 1 year step. So it's 1998. A gentleman who didn't have too much gray hair, just graduated with degrees in physics and math, and moved up to Washington State to join the LIGO group. That's me. And all the while, the gravitational wave signal keeps rolling on. And so now I'm going to focus on a period of time. So it's 1998 to 2010. And this is a period when we had our first detector. This is when we built initial LIGO. So we built it, we ran it, and we made no detections in that time. And all the while, the gravitational wave signal keeps rolling on. But then we made another detector. So from roughly 2008 to a few years after that, we made advanced LIGO. And this was a detector that was much more sensitive. And all the while, the gravitational wave signal keeps rolling on. So now I'm going to take a pause and focus on a personal experience or trip. And it's the next year. It's in 2011. As mentioned, I like to hike. I'm wearing my hiking boots now. I went for a hike late summer of 2011 with a couple friends. One of them is actually here. And we did a hike in the Goat Rocks. And I was also with my roommate who I worked with. He is a grad student at the time at MIT, super smart person. And as we were trudging up this trail, climbing a hill, I wanted to make conversation. So I asked him just a question that I always had. Because for my job, every day was pretty work. It was work where I was sweating a lot. I was getting into clean room suits, building this machine with the other LIGO members, and it was just very physical work. So I didn't really see the big picture. So I asked my friend, Nick, I asked him, as we're climbing up this trail, how likely is it going to be that we make a detection with advanced LIGO? And without skipping a step, he said, within the first couple years, we're going to make several detections. And then he kept going. He talked about the rates, the type of detections we would make, and I was losing my breath. I was climbing a mountain, but I was also thinking about just what he just said, just the big picture. We got to our camp a couple of hours later, and I remember laying next to that campfire and looking up at the sky as old snowy mountain silhouette loomed over us. And I remember thinking, what would it be like to be at LIGO when that first detection is made? That was September 25th, 2011. And all the while, the gravitational wave signal keeps rolling on. Now it's September 13th, and it's about 11 p.m. Advanced LIGO is operational, and it's collecting data for the first time. And I'm on shift. It's 11 p.m. I have an hour left of my shift. I was given the keys to the detector, and so I took it to a state where it was ready to collect data. At that moment, the gravitational wave signal from those two black holes was just beginning to enter our solar system. So it was only hours away, 4 hours about. And all the while, it continued to travel through our solar system. So I'd like to reflect back on our original story. We have two black holes. They're going to crash into each other, send out this signal. This was a long time ago, and then they're going to form that one single black hole. That was 1.3 billion years ago, or 1.3 billion light years ago. It's September 14th, and it's 2:50 in the morning. I'm at home, and at that moment, my head was just hitting my pillow, and as my eyes were closing, the signal from those two black holes passed right through me. And it passed right through all of you. It passed through the Palm Springs of Washington. And it passed through the Earth in a fraction of a second, so less than 1 second. It was right through the Earth. That's the end of that parallel story. So the signal is just going to keep on going through the universe at the speed of light. But this time, the signal was recorded and detected with our machines. A couple minutes later, supercomputers that look at our data in real time or live saw a signal in Louisiana, and then 0.007 seconds later saw it in Washington State. Louisiana always never lets us forget that. They saw it first. When the computers make that detection, an automated email is sent to all of the LIGO labs. So we have scientists all over the world. And so an automatic email was sent to everybody. And in Germany, it was almost lunchtime. It was about 11 o'clock. And this is when the first scientists saw that email. This email called both observatories in the US in the middle of the night and asked how things were going. A couple minutes later, this scientist would write the historic email about what just happened. And all the while, that signal keeps going through the universe. So the LIGO lab has about 1,200 scientists involved. We all have our personal stories about how that signal touched all of us. So I'm going to focus on mainly my story and how it affected me. So the next morning, my morning ritual is to first wipe the sleep out of my eyes, grab my laptop, and then check to see how our detector did over the night. And then the other thing I do is check my emails. And one of the emails that stuck out immediately was one that had the subject, "A very interesting event." This email had tons of replies to it. And I think it was at that moment, while I was half asleep on my bed, that's when I thought about history. How we are probably connected to history, and that in that arc of history, all of us are now connected to Albert Einstein. And so it's mind-boggling when I still think about it. I almost cry every time. I went to work later that day. There wasn't confetti on the ground, there wasn't empty champagne bottles, but you could tell that something was definitely up. It wasn't for a couple of days, but then we finally got to see what the data for our detection looks like. And this is it, these wiggly lines that we have here. What you're seeing here is just a quarter second, or about a quarter of a second of data from both of our detectors. The blue is Louisiana, the red is our detector in Washington. And what you're seeing is that last moment when the two black holes crash right into each other. When I saw that picture, that was when my heart was hijacked by black holes. One thing that's interesting about that picture is that with our detectors, the other thing that we can do is that we can also listen to that data. Gravitational waves aren't sound, but the way our machines are made, you can just take that data and plug it into a speaker, and so we could listen to it. If we could turn that up, I'd like to rock this one out. I'll play it one more time. So that's the actual data. It's a very loud signal. And here it is again with a frequency shifted, just so it's a little bit easier to hear. Some people have that as a ringtone. When I saw that image and when I listened to those chirps, I tried to think about what feelings I had when I saw and heard them. And the only thing I could think of is what it would be like to be a parent. What it would be like to see your child's ultrasound image for the first time. I imagine there's awe, I imagine there's joy, and just thoughts of your life being changed forever. Listening to that chirp sound is similar to would be similar to listening to your baby for the first time in an ultrasound. And those are the feelings that I had. I'm not a parent, I just have a dog. But I imagine that must be what it feels like. That signal made a mark on all of us, figuratively and literally. Some people were even crazy enough to get it on their body. They're marked on their bodies. And actually, that's me. I got this on Albert Einstein's birthday, March 14th, which is also Pi Day, in 2016. Oh. When I saw that signal for the first time, I knew that for sure that was going to be put on my body. The reaction that we had from that first detection was astounding and surprising and humbling. We were on the front pages of newspapers all over the world. We were on Saturday Night Live. We were on a t-shirt of Sheldon from Big Bang Theory. But I think the pinnacle was when in October of 2017 at about 3 in the morning, I woke up and saw a live stream of the announcement for the Nobel Prize in Physics. And that's when Ray Weiss, that scientist from 1972, and Kip Thorne and Barry Barish were announced as the winners for the Nobel Prize. When I heard that, within hours, I was looking on Travelocity for airplane tickets. I knew that I didn't care if I had to take vacation days or pay my own money. I knew that I was going to go to Stockholm, Sweden, and tailgate outside of the concert hall as each of the founders of LIGO received their medals. And of course, I would be dressed for the occasion with my tuxedo t-shirt. And I also shared this with my family. And one of the interesting things with that is that there was no hesitation. They wanted to come too. And so this is me and my siblings. Those aren't the actual medals. Those are chocolate replicas. The actual medal is about this big, and it's a lot heavier. And we'll have Ray gave each of the observatories one of the replicas. So if you come for a tour, you'll be able to see one. When I think of all the accomplishments that all of us have done with LIGO, there's 1,200 of us. Having my hands on this machine, touching the metal and glass of this machine, and then having it moved by events on the other side of the universe. The accomplishment that I think I'm most proud of is probably the one where I get to work with my mother. My mom's name is Sharon Yellowfly. She's Blackfoot. And when we made the announcement for the detection, we wanted to share the press release into as many languages as possible. And when that was mentioned, I thought, wouldn't it be freaking badass if we translated the scientific document into an indigenous language? And that's what we did. So a lot of the words are directly translatable into Blackfoot, but there's other new words that are also there. So gravitational waves, there wasn't a Blackfoot word for that. General theory of relativity, there wasn't a Blackfoot word for that. So after introducing my mom to Albert Einstein, gravitational waves, and black holes, my mom had to be a 21st century code talker in astrophysics and translate these new words into our language. And so essentially she became a poet for Albert Einstein, and made these new beautiful words in our language. One thing I want to share is just when I filmed my mom saying these words in our language. I'm not going to show the whole thing, just part of it.
Mustisk LIGO, ita pohku quis udaspumuk mixisk National Science Foundation, NSF, ki mixisk Caltech, ki MIT, annikskai utquinipua, ki apistutsimia, ki otuskia, otwitsikatumia.
I put my mom on the spot with this because she's used to just speaking the words. So she had to look at her translation, look at those large Blackfoot words, and then translate it. So I was putting her on the spot. So she was a trooper. I also have the last end of me filming her, and I always like to show this one.
Mi LIGO neskskatsimia.
Yay.
Son of a biscuit.
So that first detection was 3.5 years ago, roughly. The signal from those two black holes have already traveled 3.5 light years from the Earth. And in that time, we've made a total of 11 detections. 10 of them have been similar to that first one, two black holes crashing into each other, 10 of those. And then one of them was the collision of two neutron stars. And so that's another beautiful one that I don't have time for. And all the while, the gravitational wave signal keeps rolling on. Thank you.